Day 491 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3495, minimum operations to make array element 0. The difficulty level is hard, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, comment, subscribe, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given a 2D array queries where queries of I is the form LR. Each queries of I defines an array of integers, nums consisting of elements ranging from L to R, both inclusive. In one operation, you can select two integers A and B from the array, replace them with floor A divided by 4 and floor B divided by 4. Your task is to determine the minimum number of operations required to reduce all elements of the array to 0 for each query. Return the sum of the results for all queries. All right, y'all. So that may seem a little bit confusing at first. So let's go ahead and take a look at these examples to make sure that we are doing this problem correctly. Now, the first thing I want to go over is just real simple. What is floor, right? It says floor A divided by 4 and floor B divided by 4. All this floor means is we are going to round down to the closest integer. So say we have 2 divided by 4, that's going to be 0.5, right? Normally this 0.5 would round up to 1, but when we floor it, we're rounding down always. No matter what it is, we're rounding down. So after we floor it, it's going to be 0 because we're rounding down to the nearest integer. Similarly with this, say we had 3 divided by 4, right? That's going to be 0.75. Same thing. We're flooring it means we're rounding down always. So once again, that will be 0 after the floor, right? Let me just put floor over here too so you can see. But so yeah, it's always rounding down no matter what it is. So that's just important to understand because we're going to need to know that when we are answering our question, because normally this will round up to 1 and this will round up to 1, but since we're flooring it, it always rounds down. Similarly, let's just say we had something that was 3.75, right? That would, after flooring it, that would be 3. If we had 1.77 after flooring it, that would be 1. It's always rounding down, y'all, so just keep that in mind. So now that we know what that is, let's get into these examples. So in example 1, we have our queries equals our input queries equals a 2D array of integers, first array 1 and 2, second array 2 and 4. So the output is 3. Let's go through the explanation. It says for query 0, which is this query right here, 1 and 2, it says the initial array is nums 1 and 2. Boom. So in the first operation, we could select nums of 0 and nums of 1. The array becomes 0, 0. Why? Because 1 divided by 4, that's going to give us 0.25. Once again, we floor it 0. Then 2 divided by 4, once again, that's going to give us 0.5. Once we floor it, it's equal to 0. Boom. So we could do that in one operation, right? So now that we did, that's just for queries 0. So now let's take a look at queries 1, which is this array, because remember, we have to do it for each array in the input. So this, we could do this array right here in one operation. We could get both of these down to 0 in one operation because it says we could select two integers from A and B. So for 1, there's only 1 and 2, right? Because 2 comes after 1, there's no numbers in between, and then we floor both A and B, so we floor 0 and 1 and 2. That all fits in the same operation. This is all one operation. We could floor two numbers in one operation, so that's why we were able to do this in one operation. So let's look at queries of 1 where it might take a little bit more operations, right? So because this time we have 2 and 4, which means we want the numbers, sorry, let me see what queries, defines an array of integers non-consisting of elements. Yeah, right here, ranging from L to R, right? So in this case, we have 2 and 4, but it's a range from 2 to 4, so that's why this 3 is included. Where in this one, it was just 1 and 2 because since 2 comes after 1, there was no other numbers. But this time, we're dealing with 2, 3, and 4 because this query is from 2 to 4. Boom. So it says in the first operation, we can select 0. Hold on, let me come over here so y'all can see better. Let's say, so we're starting with 2, 3, and 4. Boom. For 2, 4. That's going to become 2, 3, and 4. Then boom. Okay, so now we're working with 2, 3, and 4. It says in the first operation, nums of 0 and nums of 2, the array becomes 0, 3, and 1. So in our first operation, we're looking at nums of 0, which is this 2, and nums of 2, which is this 4. So we could do the same thing, right? So 2 divided by 4, that's going to give us 0.5. Sorry, 0.5. Boom. Then when we floor it, that's going to be 0. Boom. Then we're doing 4. So 4 divided by 4 is going to equal 1. 1, we don't have to round. It's already at an integer, right? So there's nothing we can do. Once again, floor rounds down to the nearest whole integer. 4 divided by 4 is already a whole integer, so we're stuck at 1. And now this array, right? So this 2 becomes a 0 after that. So let me see. 2 becomes a 0 after this operation. Then 3 stays the same. We didn't touch 3 yet. And then 4 becomes 1. And that's how we get this right here. Boom. But that's one operation. We want all of the elements to be 0. Right now, we had one operation and only one element is 0. So now we got to do it again. Then it says in the second operation, select nums 1 and nums 2. So that's this 3. That's 3 is nums 1 and 1 is nums 2. Then the array becomes 0, 0, 0. So now we already have 1, 0. Then we do 3 divided by 4. That's going to equal 0.75. Once again, we always round down to the nearest integer. So that's going to be 0. So now this 3 becomes 0. Similarly, we do 1 divided by 4. That's going to equal 2, or it's going to be 0.25. And once again, once we round that down to the nearest integer, that's going to become 0 as well. So now our array is 0, 0, 0. And that's how we got it, y'all. So I hope that makes sense to y'all. Just in case it doesn't, actually, we're not done yet because we still, as we can see, we did this and, we did this one in one operation. Then we did we did this one in one operation. We did this one in 2 operations. So we add those together. 1 plus 2 equals 3. And that's how we got 3. Boom. So now that we understand that part, or I hope we do, let's go ahead and take a look at example 2 just in case people are still having some issues. So in example 2, we have our input queries equals a 2D array of integers. This time it's just 2 and 6, right? So now we're looking at 2 and 6. Sorry, y'all. 2 and 6. Now remember, we want all the numbers ranging from 2 to 6. So I'm going to just put those right here. 2, 3, 4, 5, and 6. Boom. Sorry, y'all. Boom. Okay. So this is our range. This is this is the query. And this is the range. Boom. Boom. Oh, sorry. Boom. Okay. So now we have that. Oh, let's just change this to query so it can match. Boom. So now we have that. So now we have our range, right? So it says the initial array is 2, 3, 4, 5, and 6. That's what we have right here. Boom. Then it says in the first operation, we're going to select nums 0 and nums 3. The array becomes 0, 3, 4, 1, 6. So nums of 0 is this 2, and nums of 3 is 0, 1, 2, 3, and this 5. So we're going to do the 2 and the 5. Boom. So when we do that, 2 divided by 4, once again, that's going to equal 0.5, so we can floor that to 0. Then we do 5 divided by 4. And 5 divided by 4 is going to be equal to 1.25. And so after we floor that, that becomes 1. So now, after that's one operation, so we could say operation plus equals 1, right? So now we have that's one operation. Boom. Then we are going to, so now our array is, so we change this 2 to 0, so we have 0, should come down here. So we have 0, this 2 became a 0, then we still have, sorry y'all, let me clean this up. So now we still have 0, then we have 3, then we have 4, this 5 became a 1, right, because of this right here. Sorry, this should be 4. So this 5 became a 1, and then we still have 6. Boom. So this is our new array right here. This is it right here. So in the second operation, nums2 and nums4, the array becomes 0, 3, 1, 1, 1. So we're going to take nums of 2 and nums of 4. So this is nums of 2, this is nums of 2, which is 4, and this is nums of 4, which is 6. So we're going to do those two. So 4 divided by 4 equals 1. That's still going to equal 1 after we floor it. And then we have to do 6 divided by 4, that is going to be equal to 1.5. So after we floor it, that becomes 1 as well. So that's another operation. So we could say operation, or let's just say operations equals 1. Now that's a second operation. So now operations equals 2. And our new array becomes, so we just did the 4 and the 6. So now our array becomes 0, 3, 1, 1, and 1, right? Because this 4 became a 1 and this 6 became a 1. And that was our second operation. So now we're looking at this as our new array. Boom. So let's just copy and paste this down here. Boom. So now we're on our third operation, right? So it says in the third operation, we select nums1 and nums2. The array becomes 0, 0, 0, 1, 1. So we're going to look at nums1, which is this 3, and nums2, which is this 1. So now we're going to floor the 3, or we're going to do 3 divided by 4. That's going to equal 0.75. After we floor it, that becomes 0. And then we do 1 divided by 4. That's going to equal 0.25. After we floor it, that's going to equal 0 as well. Boom. So now our array becomes 0, 0, 0, 0, 1, 1, right? And then that's our third operation. Boom. Now, last but not least, we have to do, well, let me just put this up here. Boom. Last but not least, we have to do these two integers right here, or these two elements right here. So boom, let's just bring this back down here. So now it says in the fourth operation, we're going to select nums3 and nums4. The array becomes 0, 0, 0, 0, 0. So now we're doing nums3 and nums4, which is this. So once again, we do 1 divided by 4. That's going to equal 0.25. After we floor it, that's going to equal 0. Same thing again. 1 divided by 4 equals 0.25. After we floor it, that equals 0. So now our array becomes, or actually, let's put it, oh yeah, now, sorry y'all. Now our array becomes 0, 0, 0, 0, 0, 0. Boom, and that was our fourth operation. So our output is 4 because it took 4 operations to make the whole array 0. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all. We should be able to get through it fairly quickly. So let's get started. Now, first thing we're going to do is we're going to create a helper function that calculates the weighted operations count for all of the numbers in the range. So we can come right here outside of the main function. We're going to declare a func. We'll call it count. Open up the excuse me, y'all. Open up the parentheses. We're going to say underscore a colon. That's going to be an integer. It's going to return an integer, and we're going to open up the brackets. So first, we're going to declare a variable called res. We'll set that equal to 0 to start, and that's going to keep track of the total operations that we have accumulated so far. Then we need another variable, which is going to be the current weight or number of operations per element in this block. So we could just come underneath this, declare a variable called k, set that equal to 1. Then we need the current block start value, which are going to be just powers of 4. So 1, 4, 16, 64, and so on. So we're going to declare a variable called v and set that equal to 1. Boom. Now, while we're going to say while a is greater than or equal to v times 4. Boom. So while a is still large enough to include the full next block of size v times 4, we're going to open up the brackets and we're going to add the contribution of this entire block, and each element in the block contributes to k operations. So we're going to say res plus equals, open up the parentheses, v times 4 minus v, and come outside the parentheses times k. Boom. Now we need to move to the next block. So we're going to say k plus equals 1. Sorry, y'all. That should be a lowercase k. K plus equals 1. And the next block starts at the next power of 4. So we're going to say v times equals 4. Boom. And now we need to add the contribution of the remaining elements from v up to a, each needing k operations. So we come outside of this, sorry y'all, come outside of this while loop, and we are going to say return res plus, open up the parentheses, a minus v plus 1, come outside of the parentheses, and we're going to multiply that by k. Boom. Now that's it for the helper function. Let's get into this main function, right? The main function, not that long either. So for the first, we're just going to create our variable to store our accumulator across all queries. So we just declare a variable, call it res, set that equal to 0. Boom. Now we're going to say for q in queries. We're going to open up the brackets, and for each query L and R, we're going to compute operations needed for that L and R, minus the operations for 1 and L minus 1, which gives operations for L and R. Then we're going to add 1 for adjustment, then divide by 2 since operation pairs are up to elements. So we're going to say, all we have to do is say res plus equals, open up the parentheses, count, open up the parentheses, q, square bracket 1, come outside of those parentheses, still inside the other parentheses, we're going to say minus count, open up the parentheses, q, square bracket 0, minus, come outside the square bracket, say minus 1. Then we're going to come outside of these parentheses, still inside the other parentheses, we're going to say plus 1. Then we're going to come outside all of the parentheses and divide that by 2. And that should be all she wrote, y'all. So let's give it a run. Let's see, okay, and we have our error, cannot find rest and scope. Let's get rid of that T and run it again. See what this does. Oh, so we got an extra, Let me see. We're missing a return. Sorry, y'all. We supposed to come right here and we gotta say return res. Boom. Now let's run it. That should be it right there. Let's see. And it's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 12 milliseconds beats 100% of users with Swift. That's what I'm talking about. That's what I like to see, y'all. So with that being said, I hope y'all learned something today. Make sure you get one more look at the code. This is the top. This is the bottom, and this is the top. And yeah, y'all, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.